Good morning, friends. Welcome back to STEM Enrichment. Let's pick up where we left off yesterday. When we were last together, we were instructed to complete a laboratory experiment relating to gravity. We took two objects and we dropped them from the same height at as close to the same time as possible. What we're going to do today is we're going to go through my results from when I completed this activity. I'll show you my lab result page and I'll show you my recorded lab experiment. Then we'll link back up and we'll discuss these results and the science behind them. Stay tuned. So if you took a look at my lab experiment, you would notice that my objects that I dropped from the same height at as close to the same time as possible hit the ground at approximately the same time, regardless of what they were. So my dodgeball and my cotton ball hit the ground at the same time, even though my dodgeball is much more massive than my cotton ball. This is because the rate of gravity is constant on Earth. So all objects will fall at the same speed regardless of their size and their shape. Now, if I were to slow down that video even more, you might see a slight difference in when these objects hit the ground. That's because of two separate factors. One of them is me. I'm a person who makes mistakes in experiments. We call this human error. So, even though it might feel and look like I'm dropping my objects at the exact same time, my human error makes it so that there's a great possibility that even though it looks like I'm dropping these objects at the same time and it feels like I'm dropping these objects at the same time, I might be releasing one of them a split second before or after the other. This could account for why one object might hit the ground a split second earlier. The next thing is air resistance. And we touched on air resistance a little bit yesterday. What air resistance is basically a force that resists or prevents the motion of objects falling. So the molecules in the air have the possibility of slowing down that gravitational pull towards the ground when an object falls. If we were to release these two objects in an area where there was no air resistance and I had no human error, they would fall at the exact same time. So regardless of the weight, mass, size of the objects that are falling, any two objects that are dropped from the same height will hit the ground at the exact same time. In a moment, we're going to watch a video that was recorded on our planet Earth's moon. So this is something that's been recorded and taking place in outer space. what you're going to see is an astronaut drop a hammer and a feather from his hands at the same height and at the same time. Now, on the moon, there is no air resistance. So I want you to take note of what happens when this astronaut drops both of these objects at the same time. I also want you to take note of the speed with which these objects move once they are dropped from the astronaut's hands. Remember, we said that the force of gravity is a force of attraction between any two objects that have mass. Now, when we're on our planet Earth, the most massive thing that anything within the Earth's atmosphere will come in contact with is the Earth itself. So that's why everything, regardless of what it is, if it has mass and it's within our Earth's atmosphere, it will feel the gravitational pull from the Earth more strongly than the gravitational pull from any other object with mass. The moon also has mass. It's also made up of stuff. But if we look at comparison charts between the Earth and the moon is less massive, or it's smaller than the Earth. So its gravitational pull is less strong. So take note at the rate with which these objects fall, and take note of the timing of them falling. So when they each hit the ground.
The Commodore Drum in the ETD.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
Beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? This proves that Mr. Galileo was correct in his findings.
Now, head to your assignment section in today's activity to answer a few questions regarding our video and what we've discussed in STEM enrichment today regarding the force of gravity.